Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of association and causation. This is standard A.4B in the great state of Texas, and we are using item number 9 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So, we need to find which situation best represents causation. Now, there's no definition given to us on the mathematics chart or any reference material, so we need to go into the STAAR test knowing the difference between association and causation. So I've put the two definitions down here at the bottom of the screen. So when two variables are associated, that means they're simply related. They have something to do with each other, but they're not as strong as a causation. So a causation is when one variable directly affects another. So we might say, or a tornado causes a house to be destroyed. That would be causation. So let's take a look, and as we read through each of these scenarios, we'll ask ourselves the question, are these two variables related? Or is one variable causing the other? Okay, so let's look at A. When the number of bus stops increases, okay, so that's our variable, that's our indirect variable or independent variable, so let's just call that X. When the number of bus stops increases, the number of car sales decreases. This is our second variable right here. And so increasing the number of bus stops, I definitely see an association, right? So that makes sense, because if you have more bus stops, that means it's easier to get around town. Taking public transportation, you might not want to necessarily buy a car. But I don't know if we could say that that's strong enough to say that increasing bus stops is going to decrease the car sales. There's a lot of reasons that people get a car, and just increasing bus stops is not going to 100% solve every single reason. Because what if you're wanting to go somewhere where there's still not a bus stop, or go out of town? So those two are associated. I could see how one might go up and the other might go down. So it has a negative association, right? If we were to graph it, it'd be like a slope like this, but still not a causation. Let's look at B. When fewer firefighters report to a house fire, the damage caused by the fire decreases. Interesting. So when the fewer firefighters report, right, there's your X, the damage caused by the fire decreases. Well, I could definitely see an association here, because fire departments are very good about sending the number of fires needed. And so if it's a very small fire, or one that they think is not going to spread very rapidly, they might send fewer firefighters. But this definitely does not cause the other, right? What you can't say is, well, that's a big fire, so what I'm going to do is I'm going to send fewer firefighters, and that's going to cause the damage to decrease. See, you can't say that. That's why it's not a causation. Let's check C. When ice cream sales increase, incidence of sunburn increase. I can see the association here, but definitely one does not cause the other. Here's the cause. The real cause is sunny days. Sunny days is actually probably going to increase both ice cream sales and the incidence of the sunburn. So there's another cause, but it's not the ice cream sales. That's just an effect of the sunny days itself. So it is an association, not a causation. When it rains several inches, the water level of a lake increases. Well, it's definitely an association. I see how when there's more rain, the water level increases. Can we say it's causation? Does raining directly increase the water level of a lake? Well, yeah. That's how the water level of a lake increases through rainfall. It's not through a giant hose that someone puts out there. So yeah, it's both association and causation. My answer is D.